I'm Larry Fine, your moderator. I guess make sure your cell phones are turned off, please. And I got to tell you, this is one of my favorite times of the convention of these presentations, so I hope you all enjoy them. I'm going to give you the code, which is CAA4, Charlie Alpha Alpha 4. Okay, with that, Don, you want to come up and introduce the first group is going to give a presentation?
Hey, good morning, everybody. My name is Don Lowell. I'm an adjunct instructor at Ferris, and in absence of Mike Barger, who's actually overseeing the capstone groups, I'm going to do a little brief introduction on each of the groups here. So this is a culmination of their 4 years of education at Ferris, or education in general, sometimes maybe a little more than 4 years. So we're going to just, without any further, I'm going to just start out. We've got, as you can see on the screen, what the topic is this morning, and this is going to be presented by Brett Bartlett and Dylan Kolbiaz. Gentlemen.
Good morning, everybody. Hope MSPS is going well. Today we're going to be talking about topographic surveying, conventional GPS versus aerial photogrammetry. My name is Brett Bartlett.
My name's Dylan Kolbiaz. We want to offer a special thank you to our surveyor in charge, Brian Bartlett, and our drone pilot in charge, Timmy McGuire. They were very helpful throughout this whole process.
So the project background, this is a field in Sandusky or Sanilac County. It's roughly 80 acres. This is for pre-solar field development, so we thought it would be a great chance to compare both results of conventional and drone. It's relatively flat, which also is another application for using both drone and GPS. So the objectives. We aim to make a highly accurate and detailed topographic map using both GPS and drone methodologies. With the GPS, we took roughly 5,250 ground shots throughout the entire field, which made our tin or surface. And with the drone, we used roughly 620 pictures with 5 different targets across the field. And we aim to compare both by using 9 completely separate check shots through both of the surfaces with the same coordinates, but we wanted to compare elevation. So we attached both of those with the same coordinates to each surface and then subtracted and found our Z value, which you'll later see. So the equipment used, we used a Leica GS-18 rover and a Leica GS-18 base station, a Leica CS-20 data collector. For the drone, we used DJI M350 with RTK, and for the software, we used Pix4D for the drone. We used Tremble Business Center to adjust our LES files, and we use AutoCAD for the rest of it. And we'd like to thank Surveying Solutions for letting us use all their equipment. So our GPS procedure, we first started by finding an NGS point and checking it with our cores. We then set the base station up on that NGS point. To start our control loop, we set all of our control. We then rechecked into our NGS point, moved our base station to the control. Then we started taking GPS shots roughly every 25 feet throughout the 80-acre field. And we used those points to create our surface. This took 2 days, so we made sure every day we checked back in with our control, make sure everything closed right. So our GPS outputs and deliverables, as you can see, there's some human error, but it's roughly every 25 foot that those 5,250 shots are roughly every 25 foot. That created our tin surface, which gives the contractor a good look at a good visual what the field should look like, what it should be designed like, if there needs to be slope adjustment, anything like that. And the good thing about using GPS is you get to select the exact field limits.
Okay, so for our drone survey, we first started by setting 5 targets throughout the field, 1 on each corner of the field and then 1 in the middle. Then we went and set our flying height at 350 feet. We did 80% front lap, 75% side lap for our flight. We did a single grid pattern. This made sure that we hit every part of the field. We had lots of redundancy in our photos. We started the flight. It took about 2 hours for the flight to complete. And then when it was done, we checked photos on site to make sure all the targets were visible and that everything looked okay and we were okay to leave, so we didn't have to come back. Then we brought our data into Pix4D to create our surface, and then Trimble Business Center to create a point cloud, and then AutoCAD Civil 3D to draw our contours. So one advantage of using the drone is that we got 3 deliverables from this. We created an orthomosaic image, provides the client with a up-to-date, detailed, high-resolution picture of the entire project site. We got our topographic map, which was the main deliverable that we were looking for. And then we also got a 3D model of the entire site. This allows the client to zoom into any areas they want to, look at it in depth, get a really good idea of what the field looks like without ever having to drive out there. So to compare accuracy, we took 9 check shots throughout the field. We laid the 2 surfaces on top of each other and pulled elevations from both surfaces. And right here's the difference. There's a couple tenths at each check shot, which we were happy with. And then our mean error throughout the entire field was only about 0.05, a little over half an inch, which we were very happy with. This gave us confidence that we performed the survey correctly, and we were happy with those results. So to compare the cost, we just tracked our hours. With the GPS survey, it took us about 48 hours in the field to drive there, topo, drive back. About 10 hours to process all of our data, and that came out to a total of about 58 hours of work. The drone, we were able to complete in one 12-hour workday, another 10 hours of processing data, so that came out to about 22 hours of work, so it was much faster, much more efficient to use the drone in this project. Both methods had their own limitations and problems. The GPS's main limitation was just time. As you saw in the last slide, it took a lot more time to complete the survey. The drone was much faster. However, in this field, it was completely open, so we didn't have to deal with tall vegetation. But in this picture, you can see there's some gaps in the data. We included this picture because it kind of shows how the drone can't see under the trees and the buildings and stuff. This is a house across the street from our project site. We just happened to pick it up in our flight, and it really shows a limitation with the drone. Weather can be a problem. Our pilot said high wind speeds, even though our drone has RTK, can really throw off the results and give bad results. We got lucky in this project. The day we planned to fly, we had perfect weather. And then another problem with the drone can be large data sets. Just with a single grid pattern, we got a lot of data. We crashed our school computer like 3 times trying to process all this data. So that can also be a problem using photogrammetry. So throughout this project, we both kind of decided if we're ever faced with another job like this in our professional careers, we would probably start out with a drone. We realized that not every field's gonna be perfectly flat and open. Where there's tall vegetation, we would have supplemented the data with GPS shots. So in the future, we will most likely lean to using a combination of flying the drone and then supplementing those over those high vegetation areas with more GPS shots.
Thank you, guys. We're going to take all the questions till after everybody's presentation, so we're going to hand it off to Ethan.
Yeah, Ethan Moore is next up, and give him your full attention as he prepares a little report on Remont.
Thank you, Professor. So, good morning, everyone. as he said, my capstone project is on this last season's Baraga County Remon. Before we get started, I want to give a huge shout out to Chris Nielsen with CHN Surveying. He was the surveyor of responsible charge for this project, and he was also just a huge source of information. I worked really closely with him on this, and I would not have been able to do this without his help. He was a huge source of knowledge. So some reasons for the project are the Michigan Remonumentation Act. Baraga County, like a lot of counties in Michigan, is currently in the process of refreshing all of their section corners. They want uniform monuments, and they want them in peer-reviewed locations for future surveyors' sake and for uniformity's sake. And I'm focusing primarily on 8 corners in section 10, which I'll get to on the next slide. So you can see here, it was in Baraga County. Specifically, we're in Lance Township, up in the Upper Peninsula, which is where I'm from. Specifically, we were in Township 49 North, Range 32 West. And as I said, we were working out of Section 10. So some history of the area. The township lines were laid out by William Austin Burt and 4 of his 5 sons. I got 4 of them on some of the LCRCs in the area. The section breakdown was done by Guy H. Carlton. I have 4 LCRCs from 8 corners on this section, and then a Remon map as well. And one thing I thought was funny that I found while digging through the LCRCs, when this was done all these corners were done in 2002 by the DNR. And Steve Siskowski, who did all these corners on corner H5, wrote in his notes that Guy Carlton seems to have laid out many short miles in this township. And I just thought that was a funny thing to include in your LCRC. So just kind of the meat of what we did. We started really early in the season. As soon as I got up there after the school year at the beginning of May, we immediately went to research, which is just pulling GLO records, adjacent surveys, basically anything that pertains to these corners that has information is useful. And then after we get all of that, it's just about drafting it up, prorating distances based on the GLO notes and recorded distances, which gets a little tough sometimes if there's nothing since GLO has been filed, which is an issue in some of these areas. As far as what we used when we were doing it, once we get out in the field, we were using the Trimble R8 and VRS as a rover when we had cell service. And then since this is an area where cell service is a little spotty, we often had to switch to, or we were using the R10 as a rover. We had to switch to using the R10 as a base and the R8 as the rover, and then moving the base around. And we were running that off of the Trimble TDL 450H radio. So after we get all the field work done and find all the corners, it's just about remeasuring any existing witnesses that we find, noting any differences that have changed since it's been recorded, which, like I said, it had been about 25 years almost, so there was some significant changes. And then any witnesses that have been removed, just taking new ones. You want 4 witnesses in each, or a good witness in all 4 quadrants for the next guy who finds the corner. And then the final step in the process is replacing the original, or the standing monument with the Burnson monument that the county provides. So here's an example of one of my LCRCs. This is for G5 and H5. You can see on the first page there, all the way on the left, that's the history. And then the middle page there is everything that we did at the corner, and then the updated information on witnesses and everything. And then here is the Remon map I ended up with. You can see it's just kind of got some basic information, streams and roads that go through the section, corner information about each of the corners, witnesses, shows the general shape of the section. It's not exactly exhaustive as far as information goes, but it's a lot of useful information for any surveyor who needs to access any of these corners in the future. So as I said earlier, we started right away in May. which is just immediately we started hammering the books, doing the research, doing the drafting, and then Chris is big on front-loading all of the field work as early as possible, so everything that we could get done right away, we did, because he would rather have us wait on the county as opposed to having the county wait on us. So once we got all of that external work done, we were able to kind of start on the LCRCs and start making the Remon maps while we wait for the county to acquire the materials that they want. Some of those you can see here on the right. There is, on the bottom there, that's the Bernson Monument. It's a 30-inch aluminum pipe with a cast aluminum base. The claim that Bernson makes is that it's an improvement on the standard pipe design, but I would firmly disagree with that. And then the Carsonite post is standard. They like that about a foot, if you can, a foot north of the corner. And then in Baraga County, they just want one placard on one of the trees. So yeah, once we get all those, that's usually, it was mid-August once they finally got all that stuff to us. And once we went back out to the corners and got all those put in, then we had the rest of the time until the peer review group to just tune up the LCRCs and get the Remon maps to where we wanted them and everything. Here's some examples of how the corners would look. The one all the way on the left there is typically how we would find them. You can see the DNR monument down there at the bottom. And then the standard used to be a wooden post adjacent, so that's what that is, leaning there. The one in the middle there is after we got done with it. That one didn't have a wooden post. It had a stick that a landowner had put there at some point. But you can see they like the old monument there lying adjacent to the new one. And then all the way on the right is another one of those that we refreshed, and then we actually still had the post on that one, so we tried to use the Carsonite post to kind of supplement it and maybe keep it standing for a little bit, because a lot of them are pretty rotted around the base. A strong breeze would probably take them out. So as far as the terrain and the conditions, it was unusually hot and humid for the summer. I've been in the UP pretty much my entire life, and it was definitely one of the hotter summers I can remember. And there was also intense fires in Canada, so there was some pretty bad smoke all summer as well. The terrain varied. There was rugged mountainous stuff, there was low swamp, there was open hills, and there was dense scrub brush. Pretty much everything that the UP has to offer is right there for you in Baraga County. Multiple times we found private roads locked behind fences that we weren't able to get access to, but on the bright side, walking on a road is a lot easier than a lot of other hikes can be. And then just out in the woods, a lot of common GPS issues. I mean, there's dense canopy. Like I said earlier, we were on the edge of cell service, so VRS is really spotty. And then when we did set up the base, it's tough to find a good spot, and often we would have to move locations as well. Here's some photos of the terrain that we experienced here. On the left there is just some rocky stuff we had to climb up. In the middle there is a nice low swamp we had to walk through, and then on the right just some scrubby brush, and these are all within a mile of each other. Like I said, it's all right there for you to experience. So I had to work closely with Chris on this because I didn't really have a gauge as to how to even estimate what it would take to do this kind of project. So this is one of those areas where he was a vital resource. And so the total guesstimation we came out to 102 personnel hours. And the actual personnel hours came out to 116. So I would say we came pretty close. And then here are just some fun examples of the stuff you get to find out in the field. There's a chubby little toad. I like to pick those guys up anytime I find them. There's that big old frog in the middle. I try to catch those guys too. I think he was a little too elusive for me though. And then on the right there, a couple miles behind a locked gate in a landowner's yard, there was what hopefully was a big decommissioned bomb. So yeah, lots of fun stuff to find out there if you know where to look. I had a great time with Remon. I'm really excited to do it again this summer. I think if I were to do it again, I could hypothetically get those hours a lot closer to the estimation. I just had a lot of learning to do this summer, but like I said, I had a great time, and I thank you for letting me share it with you.
Next up is Mason Powell doing a solo on parcel splits.
Morning, everybody. My name is Mason Powell. My capstone project that I took on this last year, took me about a year to dink around with it finally, but is on land division. So I'd like to give a special thanks really quick to my capstone advisor, Tim Platts. He was an excellent resource, great help to me over the course of my project. Also like to thank Fishbeck for resource and all the knowledge that they helped me with along the way. It was more than fun working with them. And I'd also like to thank Mike Barger, who was the instructor for our capstone group this year. So a little bit behind why I chose to do land division is mostly just wanted to get more knowledge about it. Never really had to deal with the law itself, but really liked going through the process. Compare plating process against exempt splits, which is really what I really wanted to know more about. So it was basically what I undertook. Also wanted to know, where do you find information about local ordinance? Never really had to deal with that. So a little bit about the background. Had to go through the Land Division Act 288 of 1967. Sections that are pertinent in that one is 108 and 109. Basically, 108 describes parent parcel, unit and tract, number of parcels resulting from division, limitations, requirements, basically what can I do, what can I not do. And 109 is just basically the approval process. My capstone project, I'll get to it soon, but basically I have 5 divisions. Survey requirements, since I'm going the exempt route versus going through the planning process itself, I'm still subject to the Certified Survey Act 132 of 1970. So basically, Section 1 describes the recording process. Section 2 requires what's going to happen in the field. And Section 3 requires the maps. So basically, the final drawing. So a little bit about the project description. The parent parcel's description is the south half of the northwest quarter of the southwest quarter of Section 10, well, Section 3, Town 10 North, Range 10 West, Kent County, Michigan. Total acreage for the parcel after I got all said and done, found it to be 20.16 acres. A little bit about the research. I had to pull the north quarter, south quarter, east, west, and southwest corners for the LCRCs. Got done with that, did a little bit of field work, and I'll talk about that in just a second. Didn't happen to find, I went to the Kent County Register of Deeds, didn't find any previously recorded surveys that were pertinent. Unfortunate. A little bit about the field work. As you can see, I tied in section corners, looked for the property corners and occupation, and did a drone photo flight with a Mavic 300 with a P1 photo camera. As you can see, I got a rough KMZ that I drew up in Google Earth, kind of outlining the project and its total area. Didn't happen to find any of the property corners when I was out there doing my survey, but did find an old fence line that was downed along the east line of the parcel. Checked that to my line that I had broken down in the data collector, checked within a foot pretty much everywhere, so I felt pretty good about the boundary. A little bit about the office work. Did some drone flight processing using PixElement, and as I said, I did do a photo flight as well. Currently still processing that, had the same issue as the first group, keeps crashing the computer at school, unfortunately. Drafting the project in Civil 3D. A little bit about the local requirements. It's in Nelson Township in Kent County. So Kent County Road Commission and Health Department. The Road Commission requires that each new parcel has at least 100 foot of road frontage. Currently I have 264 for the frontage, so looking pretty good on that front. The Health Department, they require that each new parcel also has a new permit pulled for having new well, new septic, and site inspection. So subject to that as well. Nelson Township also happens to have its own land division ordinance. Minimum lot size being 2 acres with a depth to width ratio of a maximum of 4 to 1. So a little bit about the current progress. Need to just finish up the final drawing. Currently, it's not annotated, as you can see, but lot size being about 264 on the frontage and about 660 in the back for the depth. So meet the 4-to-1 ratio. Like I said, it was a 20-acre parent parcel. So each new parcel that I'm describing here is going to have at least 4 acres. And then just need to write the legal descriptions. A little bit about the cost analysis. This is just what I figured it would take. Took me a lot more, believe it or not. Research and review, 6 hours. Field, 8. Office, 8. So about, I figured 22 hours total. The cost, I just put some numbers up there. Thank you for your time.
Normally, these capstone projects involve groups, and we've had a couple of individuals, solos this year. The last one is the largest group. We got John May, Blake Farmer, and Derek Demersky. Going to talk about a tunnel scan.
Good morning. Our 2026 capstone project was a LiDAR scan of the utility tunnels that run under the Ferris State campus. So during our research portion of the project, we didn't find much, but we did find this nice article from the Ferris State Torch with some rumors of the tunnels, and it talks about how there could be secret treasures down there. It was maybe a place that students used to be tortured. Now, obviously, none of that was true, but I thought it was a fun article. So the location, it's right in between the Wink Arena and Henderson Hall by the Southwest Power Plant. It's highlighted there by the red line. It just runs mostly under the sidewalk there. And the problem with these tunnels, you can see there from the pictures on the side, that's the insulation on the pipe, and it's extremely deteriorating at a fast rate due to high moisture content in the tunnel. It doesn't really have a good way to escape. So it gets damaged a lot. And the tunnel is about 800 foot in length, and there's roughly 30 foot of grade change that goes down that hill there by the Wink Arena. And the steam is used to heat the campus, and there's also electric lines that run down there as well. And you can see at the bottom picture, that top pipe is the steam line, and the bottom one is the condensate return pipe that recycles that water that's used from the steam and sends it back to the power plant. So the description of our project, we plan on scanning that 800-foot stretch of the utility tunnel with the Trimble X9 LiDAR scanner, and then we would use the images and the point clouds collected to aid in inspection and make a clean 3D model of the tunnel. And like I said, the deliverables, we're going to look to make a BIM model and then potentially a 3D walk through the tunnel. And with that, I'll hand you up to John.
Thank you, Mr. Farmer. So my portion of this project, I primarily dealt with the practical scanning. So I was down in the tunnels running the X9 scanner. And this took us 38 scans in total, 20 foot between them over around 800 feet of tunnel. And that spacing I decided was going to give us the best overlap between us to get our point cloud out with enough space between it to make a nice surface out of, along with making it so I'm not spending 500 hours down there scanning every 5 feet. We auto-registered scans to each other in the field with Trimble Perspective, which meant we didn't have to set control at every scan, and we didn't have to go through and pick it out once we were done. It was just everything linked up with itself. So that saved us a lot of time, and then we geo-referenced our scan via control at the hatches, which we'll get into later. So equipment used, we use the Trimble X9 stationary total scanner and a TX10 tablet provided to us by Siler Geospatial. And here you can see Mr. Farmer down in the tunnel moving it. This is a good example of how we were actually doing this. We were setting it up, hitting the button, scurrying away as fast as we can so we're not in the scan, letting it do its thing, and then going and moving it again. For the raw data, we ended up with 187 million points. Here's a picture of what I'm looking at in the tablet when I'm down there, making sure each scan's registered correctly. We had 3.1 millimeters of error with an average overlap of 62% and a 98% consistency, which I think was pretty good for our application. Issues, here you can see where I was wrong with my picture, and I have a cockeyed scan where the points are coming off either end. this is one of the issues you're going to run into with this, where the auto registration doesn't like tunnels because everything looks the same. There's no prominent points to pick out, so you have to go in and do it yourself in the split view, which you can see above that. That's an example from the top floor of Swan, where the tunnel's really the hallway looks like a tunnel because it's really thin. And we've figured, when we're doing our research phase, that this will be a good way to set this up where we don't need to get down to the tunnel and burn time. And I think that worked out pretty well for us. And with that, I'm going to hand you off to Mr. Demersky.
Thank you, John. So as for georeferencing, we decided because of the topography of the exterior of the tunnel that we would use a linear traverse. As you can see here, we used these access hatches where we were able to shoot in scan control and stick like a rod out in front of it. So we held a local NGS point and we traversed to another known point. And we had 5 exterior control points and 5 scan control. We also had a couple bolts that we used. So for the equipment we used a Trimble R980 Rover with a TSC5 data collector, a Trimble S5 robotic total station with the TSC7, so some of the issues we faced were GPS errors, which you may know about. And then there were scheduling conflicts because every time that we had to go in the tunnel, we had to be supervised by staff. And so it was just challenging to have everyone on the same page. We were also reminded that it snows in Michigan. So when you go back to the control point that you've had and there's a big old snow pile on top of it, that can also be a challenge. So the 3 main softwares we used for processing was Trimble Business Center for our point cloud. We used Autodesk Recap as well, and we used that to make a preliminary mesh, and Rhino 3D for our BIM model. So for processing in Trimble Business Center, the version that we have, there's an auto registration that you can use for indoor, and it only does the floor, ceiling, and the walls. So we had to manually go in here and extract all the pipe and these brackets, as you can see.
So for our BIM model here, you can see in the pictures it's side by side with the BIM model and the pictures from the actual LiDAR scanner in the tunnel. And you can see those main features that we have extracted from Trimble Business Center, being the floors, walls, ceilings, and the pipes. We still have to add some details in there, like some of the valves and the brackets, which those were a pain to extract and classify the point regions in Trimble Business Center, along with all the noise that were in there. So we ended up using Rhino 3D software. We had a lot of difficulties trying to figure out how to make a BIM model because between the 3 of us, we have 0 experience doing this. So it was definitely a learning experience. But luckily for us, we have a good friend in the architecture program who uses models like this all the time. So he ended up bailing us out here and helping us make this 3D BIM model. So the overall issues, like I said, we have a lack of experience in this area, and that's one reason we chose this project, so we could get more experience with LiDAR scanning and these 3D models. So we had issues in TBC, like I said, and then the Autodesk mesh needed to be cleaned up. You could see that pictured in the top. There's still gaps due to lack of density in certain areas of the point cloud, because due to the confinement of the tunnel, when the LiDAR scanner is so close to the wall, it leaves a gap where it's not as dense in the point cloud. So you need another software to go and clean that up. And then finding a software for a BIM was also challenging that was usable. So we're overall time. We had a lot of time, in total 84 hours. We had a lot of time spent in research and processing. And we definitely could have cut down on a lot of that if we had the experience to do this project beforehand. So if we were to do it again, we would have we would have known what softwares to do. We would have known what, we would have been able to establish a good workflow between going to TBC to Autodesk to Rhino 3D, and we would have had a better game plan going into it. That would have helped a lot. And then potentially getting something like a SLAM scanner to get in the finer areas of the tunnel where the LiDAR scanner struggled because of all the insulation falling off the pipes and other various hazards down there, things getting in the way. So I'd like to give a special thanks to Siler Geospatial Instruments for giving us all the equipment. Luke Baumgartner, who was the HVAC supervisor, who was down there in the tunnels with us every time we were down there opening the hatches with us. Professor Mike Barger, who was our capstone professor this year. Luke Enyart, who was the architecture student that helped us come up with the BIM model. And Tom Patrikas, the Ferris physical plant admin. Thank you guys, thank you for your time.
Sure you can. Okay, works for me. Guys come right up here so everybody can hear.
It's the rock pot.
Maybe you could repeat the questions for everybody.
So he asked if we had a check shot on a ponded area, but it was actually a rock pile there that you were looking at. We did have check shots through there, and those areas did check into each other, like within a couple tenths. Like.
Also have a question too. I noticed on your screenshot you had a comparison of your control points and the residuals for the elevation. Did you also have a comparison of the GPS points throughout the project with extracted data from your mapping from point cloud from the photograph?
So those are completely independent. All 9 of those check shots are completely independent, same coordinates, but we wanted to stick them straight to both surfaces. So we just compared those residuals, so we got an even.
Yes.
It was 80 acres. 80-acre field? 80 acres, yes.
So most solar farms now are like 1,000 acres. So in doing 1,000 acres, as you stitch these drone photos together, is there a certain distance that you find that helps eliminate the, as you would say, as you stitch them together using your vertical, is there a distance that you need these check shots or photo control points to take care of that loss of elevation accuracy in stitching?
So we don't have much experience with 1,000 acres, so I don't really want to speak to that without any expertise on it. So sorry.
For processing the data, you said that processing was a challenge for you because of too much data. Was there a chance you could thin that data, the density of that one point per foot, square foot there, or no?
So the raw data, so when you put it in Pix 4D, it just gives you, we had 9 LAS files, and it was 12 gigabytes. And I'm not sure if you can thin that out.
When you export that one, you cannot select density there?
I don't think so, not from Pix 4D, no. Because we got to move it into Trimble Business Center to then classify it, break it down. So like that's the hardest part, is bringing it from Pix 4D, being LAS, to then breaking it down.
So when you guys ran into those issues with your stuff crashing, it was in Trimble and not in Pix 4D? Am I correct in assuming that?
Yes.
Did you guys try and separate, trying to
So we did like one by one. We started one by one and then we did four or whatever. But the hardest part was classifying it because we wanted ground because you need to make a surface. So we had to classify it, get our ground. Then after that we can make excuse me, ground shots with that ground classification. That's how we get our ground, put ground shots surface.
Okay, thank you.
Yeah.
How many of them had a tie actually back to the government corner where you could say that that was an existing corner?
All 8 of them in this case were DNR corners, and
They make mistakes too, so.
I would have to defer to my employer for that. There's certain decisions that, as a technician, were a bit above my.
Well, back in your A part there, you should have that listed, and you're starting with the government corner and then bringing that history right down through there. So you should be able to look into that part A and see if there's any ties, between A and B and go back to them. So that's my question, and then I guess if that's what you need to look at.
I guess maybe I'm misunderstanding your question then.
Okay, you was all the way back to the GLO information on that corner, whether it's post set stakes and whatever, with business on it. As you progress down through where the next surveyor was in there, whether it was DNR, did the DNR say that they found the post? Did they say that they found the original?
For Baraga County, I think there was only one where they still referenced the original GLO monument. It was a 39-inch yellow birch, and I believe originally it was, when it was called for, it was like 6 inches.
There's the right answer.
Anyone else?
Question for you.
Yeah.
So when, did you conduct a research for the core of history when you were doing the project?
I did a lot of the research, yes.
Did you have any problems researching information for the corners? Or is it all done locally at the registrar's office? Or?
Yeah, most of it was at the registrar's office. Baraga County is good about that. It's really the more rural ones, like Keweenaw County, is when you start to find some issues with that kind of stuff. But with Baraga County, it's lived in enough that there's enough information recorded. There's a lot to reference.
We better go to the next group here pretty soon or we'll run out of time.
Questions? Yes.
I think one of your comments here was that a bunch of cost comparison. You said you never came up with a final cost on it. I know you're not done through the project, so this I guess would be pointed at all of you to pay attention to what that is. Because when you get out in the real world, your bosses are going to pay a lot of attention to what that.
Yeah.
Your estimate, their estimate, and what you actually put into it.
That was just what I figured it was going to take to actually do it. If I knew everything, but I don't, unfortunately. Like I said, my advisor, he's sitting right behind you.
You won't be expected to, but.
He was an excellent resource in finding the information on the local ordinance. I was spinning my wheels and, yeah. Any other questions? Yes.
You mentioned that there was some more work to do, writing the compiling the legal descriptions and.
Yeah.
Do you have an idea, estimate of time, how much it's going to take to complete the rest of the project?
I'm just assuming it's going to be about 4 hours, just sitting down, putting things in title blocks and finishing out the legal descriptions. Maybe a final consultation with my advisor and just make sure that he's agreeing that my descriptions are correct. Any other questions?
On the parcel that had 2 road frontages, does the township require you to list one as front and one as side?
I don't know. That's actually a great question. Looks like it's a yes. Any other questions? Thank you.
Any questions?
Just one for me. I think you mentioned in there you struggled sometimes to register your scans in that tunnel. Is that because you were just
we set targets. You can see those chevrons. I can go back, but you can see the chevrons in the control slide. No, we're not.
Oh, all right.
Sorry.
You,
Yeah.
he goes in on the actual tablet. You pick common points from there, and it's able to register. But it auto registers, but sometimes it does it wrong, so you have to manually do it.
So the auto registration can get it wrong, like in the scans where we're showing.
It's not.
It's not. Oh yes, it is. It's up there now.
No.
It's back. It's returned. Here. So at the top there, that's what I'm doing on that. If it doesn't auto register correctly, I do have to select common points in the split screen function, and that gets it right most of the time when it does actually. If it goes through, it normally gets it right. This is one of the rare cases where it gets it wrong, and normally you can see that in the model. I was moving along and I didn't take a top view like I should have, and it got away from me, and I found this.
Is that because it wasn't picking up the two targets?
It was because its solution to line up the scans was incorrect because I chose 4 points when I was doing the registration.
Would it help if you numbered those chevron signs in your scan?
So I think we took it out, but we.
Number there?
Yeah, so our chevrons are numbered, but also I'd number on the wall where I could see it in the scan. I'd either in tape or write the number of what scan it was so I could see what it was. But like I said, it was just I didn't. It still gets it wrong sometimes. It's a tunnel. It doesn't have a lot of prominent points to lock onto, so it happens. If you're paying attention, you can mitigate it.
Sometimes, I think we use the case of the scanner itself, and you can see it in both views, and then you can just pick it on either side, and that, just moving it along with each scan.
We could also use the ladders, like you can see there. You can see ladders from a lot of different scans, so you can hook onto a ladder as one of your points, and then you can choose a similar bracket that's holding the pipe and the wires as well. Those would work very well for doing this.
In the back.
When you guys were going through this, did you play with the scan density to see if there was a slight difference in the best way to be able to proceed at a quicker rate and still get good amount of data?
We didn't really mess with scan density. I was happy with where it was at. It was taking 2.5 minutes to get through a scan, the little scanning portion. The photos were what would eat a lot of our time because it was low light, and we wanted to have photos for when we're going through and classifying it from the scan view. It makes seeing what things are a lot easier. But since it was low light, the exposure would have to be turned way up, and it'd take around 10 minutes to get photos, maybe a little less.
Good question. One of your slides showed a relatively small access port. Was this considered a confined space, and did you have to go through any training in order to do that?
No.
No. Well, we had our supervisor from HVAC there, and we just pretty much did what he said. Wear a hard hat down there most of the time. Watch your head when you're down there. Don't touch the steam line. It'll burn you. That was about it. Do you have a question, sir? Anybody else?
Okay, thank you.
All right, thank you guys.